Welcome to the Intelligent Power Grid demo. We demonstrate that offloading the phasor data concentrators applications in the FLUIDOS computing continuum enhances the resiliency of the system. Phasor data concentrators, PDC, collect electrical quantities, such as voltage, current and frequency from the phasor measurement units within RSE Distributed Energy Resources Test Facility. PDCs are composed by two key components: a collector part which gathers real-time data from PMUs and a database part which stores PDC configurations for efficient management. Our setup consists of 3 FLUIDOS nodes, each one made by a single node K3S cluster running on a dedicated server. One node will play the role of a consumer and the other 2 as providers. The consumer server utilizes FLUIDOS to acquire resources from the 2 provider servers. The consumer node has the capability to orchestrate and schedule applications across both provider nodes. The consumer node deploys the low-level PDC application on the FLUIDOS provider 2 node and runs the high-level PDC application locally. Additionally, it schedules a distributed database across the entire FLUIDOS computing continuum, ensuring persistent storage of PDC configurations across the 3 different clusters. It's possible to connect to the low-level PDC with a graphical user interface, where the measurements collected in real time from a PMU of our RSE Distributed Energy Resources Test Facility are displayed. This represents the operator's perspective. Additionally, the high-level PDC graphical user interface can also be displayed, with the data coming from the low-level PDC. The first scenario illustrates how FLUIDOS enhances resilience when the consumer node becomes unavailable. In this situation, the isolated provider node remains fully functional, continuing to operate independently without disruption. By shutting down the consumer node, the high-level PDC stops functioning, while the low-level PDC continues to operate seamlessly. The dynamics of the scenario can be visualized in a custom Grafana dashboard, showcasing simple metrics of our workloads, received packets, CPU usage, and memory usage from the perspective of Provider 2. Real-time data confirms that Provider 2's workloads remain operational. The provider node not only remains operational but also retains its local decision-making capabilities. New services can be scheduled even in the absence of the consumer node and, more importantly, we can leverage the resilience capabilities of the single FLUIDOS node. If the PDC collector pod is deleted, it is rescheduled within seconds on the same provider node, and data streaming is restored seamlessly. Furthermore, also the graphical user interface of the lower PDC is restored seamlessly within a few seconds. When the consumer node comes back online, the system restores itself automatically. This first scenario demonstrated FLUIDOS' ability to improve resilience. In the second scenario, FLUIDOS dynamically reallocates workloads to ensure uninterrupted service during server maintenance or faults. PMU data from the RSE Distributed Energy Resources Test Facility is collected using a low-level PDC application deployed on the FLUIDOS Provider 2 node. This node hosts both the PDC collector and a database replica. To simulate a fault, Provider Node 2 is intentionally shut down. This action allows us to observe how FLUIDOS reallocates workloads to maintain uninterrupted service. Upon shutting down Provider Node 2, the low-level PDC pod is successfully rescheduled on the FLUIDOS Provider 1 node. The system automatically reschedules the PDC application to the adjacent FLUIDOS Provider 1 node. The low-level PDC pod experiences a brief downtime of a few minutes before restarting on the FLUIDOS Provider 1 node. From the operator's perspective, operability is seamlessly restored. The high-level PDC continues to collect data automatically. The Grafana dashboard confirms that shutting down Provider Node 2 triggers FLUIDOS to automatically reschedule the PDC application to the adjacent FLUIDOS Provider 1 node, thereby enhancing system resilience. This is evident in the plot of received packets by pod, where data from the low-level PDC, represented by red points, transitions from provider 2 to provider 1. Once provider node 2 is restored, FLUIDOS autonomously rebalances workloads, demonstrating its capability to minimize the need for human intervention. This process effectively reduces both downtime and data loss and enhances system resiliency. Thank you for watching.